So today we're going to be talking about Spring Cloud Stream, past, present, and future. Some of the elements we'll be showing you are more things that already exist in Spring Cloud Stream, in the Spring Cloud ecosystem. But we're also going to be covering those things that are actually going to be coming up. So you're actually seeing me use some snapshot stuff here. So get ready, here we go. Well, first off, before we get too much further, I've got to do the ubiquitous selfie so that my boss knows that I'm actually doing work. And he's like, "Will you really do work here?" And I'm going to go, "Hey, everybody, say wave. He's doing jobs." There we go. Yay. There we go. So who am I? I am Glenn Renfro. I am one of the developers at Spring, and I'm a VMware engineer, but I work on Spring projects. One of the many things I do is I work on Spring Cloud Data Flow, Spring Cloud Stream. Hold on. Let me go right over. Spring Cloud Data Flow, Spring Cloud Tasks, Spring Batch. Yes. There's nothing wrong with Batch. Batch is good. And then when occasionally there's the lead of the project's name is Oleg, and he says, "Oh, Glenn has submitted a PR." All right. Sometimes even Oleg even lets me work on the Spring Cloud Stream project, which is totally awesome. So today, what we're going to be covering is what is streaming. I'm going to make sure that everybody in here, we're all in the same definition. Sometimes the words I use may be different than what you what you usually use, and I just want us to have a common definition. For those folks that don't know what streaming, we're going to give you a primer on that today, okay? But also what we're going to talk about is avoiding the raging river of doom, of which we're going to talk about how I go kayaking and making sure I don't die. Dying events are bad when we're working with kayaking. So we're going to talk about how I automated some of the things that I do to make sure that a creek or river or lake is safe to actually go kayaking, but with technology. We're going to be talking about functions, not bridging. Oftentimes when we talk about messaging frameworks like a Kafka Kinesis, Google PubSub, RabbitMQ, or I'm trying to remember the other one. Crap. Okay, well, I'll remember it at the end and say, that's what I was supposed to say too. Those things are, we also think about, okay, I've got to solve my problem, then I got to connect up to this messaging framework, right? Well, what if we don't have to do that? We want to focus on the functions, right? So we're going to be talking about writing functions and not worrying about how we're going to bridge to those given messaging frameworks. Then we're going to talk about functional composition. How can I take functions, put them together to create a business solution? Not just have one function in isolation, but actually have several put together. And then lastly, this is going to be a demo-rific presentation, and if you see me mess up during the demos, well, whoops. But they will probably happen as we go through. Can y'all hear me okay? I'm going to try to stay close to the microphone. I have a booming voice, but sometimes I get quiet. Summers, do I ever get quiet? No. Okay, we're in good shape then. All right, here we go. I'm going to cheat on this slide. I'm going to talk about what is streaming. I am stealing a definition here, but I will go ahead and read it out to you. Event stream processing, ESP, is a practice of taking action on a series of data points that originate from a system that continuously creates data. What does that even mean? So I'm going to go back to an example of an application I built years ago. Let me move my stuff out of the way so people have a place to sit. There we go. All right, so what it is think about it this way. I had a messaging, so I was working for a company and we were doing a lot of marketing, right? But what we were doing was we were trying to create systems for companies to be able to get in the data from social media, right? And as we're getting that data in from the social media, what we wanted to do capture information specifically from this particular type of sport that has like a foot in a ball in the United States. And what we were doing was we were trying to catch impressions from what was happening and what people were talking about. And about halftime during these games, we were particularly interested in when people were talking about when they were, hungry, right? So as where people are getting hungry, we were monitoring this, and then we'd say, hey, it's about halftime during these games. We're seeing people talk about hunger, food, whatever, things like that. And then the system would automatically send out a campaign. Hey, get 20% off if you decide to order now for this particular type of product. Boy, I'm being really vague of who this is. So what would happen in this case is then, we could always register the success of the campaign by how many people bought stuff. That's one part of it. The other part was we were still tracking how many people actually talked about the coupon and shared it, right? That's another important part. How successful was it people bringing in that conversation? So what I mean is that we're getting data in from an external system, in this case, social media. We were not only tracking just the basics to create and send a campaign out live as things are happening, but then we kind of also started watching and routing messages that saying, what is our success ratio on this? So streaming is the ability to take and monitor events and take action on those events at the time that they occur, okay? So what comprises an event, a streaming app? So we're going to talk about the 3, or actually 4, foundation pieces of an app. We got some seating up front if you want to hop up here. I promise not to yell. Come on up. We got seats there up front here, so we're in good shape. So what it is that we have source, processor, and sinks. And source is basically this. So these are the apps that will be able to take in the event. They take it from the external system, right? An external system, again, can be anything from social media, other systems. It could also be from edge devices. It could also be I'm pulling in data from other devices or other systems, or even pulling in data from what? Databases. So a source is that entry point into our system. We got seating up front. Come on in, folks. My boss is not going to believe this. He says you actually talked to people and they listened. It'll be fantastic. So the next thing is that you said 4 pieces, Glenn, but there's only 3. The next piece is that transition point. How do I get the data between source and the processor, right? That's when the messaging framework kicks in. Now you could say, well, I can send data between 2 things via HTTP, but a lot of times these messages that we are taking in from systems are critical and we don't want to lose them. So we're going to have a messaging framework like Kinesis, Kafka, Pulsar, RabbitMQ, and these things, their job is to make sure that that the data is delivered. So we want that source to pop data onto a topic or queue that's going to be taken in. The next thing we're going to have is something we call a processor. The processor is something that's going to transform that data, enrich the data, filter the data, route the data, right? And we can also see that I say 0 to N. You don't necessarily have to process data. I can send data directly from a source to what? The sink. But a lot of times we do those these particular transformations or routings, and we can have more than 1, okay, or more than 0. The last part is the sink. The sink is the thing that takes the action with the data. Now, when you say action, what do you mean? It's going to either store that data into a data source. It's going to send and route commands back to our edge devices. It could send out emails, send out social campaigns, send data to other systems. It is a thing that's going to take the action, right? So these are our basic components of what comprises a stream. Now, what's the fun part about this is this. What if I want to think about just working on the business solution? I don't want to worry about how I write the plumbing to get from my code to a messaging framework. So before we talk about that that way to get rid of that plumbing, how can I think about these problems, right? I want to think about them as Java 8 functions. What if I could write the solutions as Java 8 functions, and then what I can do is I can write a function, put it in a library, or write a function, test it in isolation, right? Put that function in a library, and then use this function in different places, and then I let the frameworks do all that plumbing work for me, okay? So we're going to talk about writing functions today, and then we're going to show you how we're going to connect a function to our messaging framework without writing code, but in fact, just setting up some properties. We're going to let Spring help us do that, okay? The first thing to remember is instead of when we look at, again, the source, we're going to use the supplier, okay? The supplier is a Java 8 function that says, look, I do not have any input parameters, right? I only return values, right? And we're going to show you in a second where I'm going to write an HTTP, or I'm going to use HTTP source that's just going to monitor port 8080, and then I'm just going to be popping data to it, and it's going to be receiving that data, and then Spring Cloud Stream is going to hook that into our messaging framework. We'll show you that in a second, but the code you'll see me write is, well, actually, we won't see that. I have a project where you could take a look and take a look at that code. We're just going to kind of spoof that right now and just run it. Not spoof it, but actually run it. Then live on stage, I'm going to go in and write a function that's going to do a to-upper, right? It's going to uppercase any data I send to it. And a function basically takes an input parameter, and has a result. That sounds like a processor, right? And then we have the consumer. And the consumer says, look, I am going to take in data, but I have no return result, meaning it's got a parameter, but that's all it has into it. So what does this look like? Well, we're going to write functions, but how can we tie these functions? And I'm going to write these Java 8 functions I can write, put into the library, and test in isolation. How can I hook these into message streaming, right? Well, the tools we're going to use is, of course, Spring Boot. I don't know why. I guess it looks good. You know, it's quite great on a resume. But then we're going to also use something called Spring Cloud Function. And Spring Cloud Function says, look, I want you to be able to write functions. But when you write a function, I'm going to give you the ability to use this function and plug it into any number of frameworks that, and you can set those as set the properties up and hook your functions wherever you need to be. Today we're going to show you how you do it with Spring Cloud Stream. But if I have, let's say, a web app, I can pull in the Spring Cloud or Spring Boot web starter, and then I can use properties to say, hey, I have this function. I want to take this function and have it be an endpoint on my MVC app. So I can actually write functions and then via properties tie it in to my MVC application. But then, like I said, we'll show you how we do it with Stream. So the goal of Spring Cloud Function, again, allow you to write functions and not worry about any underlying infrastructure. Focus on the problem. Spring Cloud Stream says, look, you want to write streaming apps? You're going to write your functions using Java 8 functions. Spring Cloud Function is going to expose that, and then I'm going to provide you the properties that allow you to tie it to a messaging framework. Okay? Does that make sense? Yeah. Okay. Well, if it doesn't, hopefully this will give it to you a little bit sharper focus. So now it's demo time. Okay? So I want to do the following. I want to do a basic stream like we had before. We'll just pop up there, where I'm going to have a supplier, a function, and a consumer. The supplier is going to be HTTP. It's going to receive HTTP messages. I'll show you the project that I used at the end. And it is going to be a supplier, and it's going to receive those HTTP messages. It's going to drop it onto a Rabbit Exchange. And then we're going to write a code of a function live here on stage. And then we're going to have a consumer that I'm going to start up. And the consumer's job is it's going to take in this function, the results with the function, which is going to uppercase the string, and write out the console. So what I'm going to do real quick is I'm going to do the Creek producer. And this is going to be our source. I'm going to start our, oops, that was the wrong thing to start. Whoops, whoopsie, that was the wrong thing. Wrong project. I meant to start my, HTTP source. I'm going to start up my, there we go, our consumer. And now let's write some code. So the first thing I'm going to do is the second best place on the internet, which is start.spring.io. As Josh Long would say, what's his favorite place on the internet, everybody? Production. By the way, say Josh, Glenn said it right. We're going to go to the 3.0.0. milestone 5 of Spring Boot. We're going to say io.spring for our group. We're going to make this uppercase, just make it sweet, UC. We're going to use Java. We're going to produce a jar. We're going to use Java 17. And the dependencies I'm going to add to my project. Spring Cloud Function, right? I'm going to add Spring Cloud Stream. And then here, I'm going to go in and say, what I need is a binder. I am going to hook into some kind of messaging framework, right? And that messaging framework can be, again, Rabbit, Kinesis, Kafka, Google PubSub, and there's like a list of 8 of them, and soon, hide the camera behind my face, Pulsar. That's coming. Okay, and then lastly we have, but today I have a RabbitMQ running locally. We're going to use it. And then I'm going to say generate that jar. Make sure I got everything right. Yep, there we go. And we're going to unzip it. Okay, it's unzipped. We're going to go to here. We're going to open my favorite IDE. And we're going to open that project and you do that. Open. There we go. And I'm going to, first thing, show you the POM file. All right, we'll go, yay, there we go. All right, so we're going to just close that. And so what we have included is Spring Boot Start AMQP, which is basically the framework which we're using for our implementation of our binder, which is RabbitMQ. That's the one we're going to hook into. It includes Spring Cloud Stream and Spring Cloud Function. Now, one of the most common questions is Glenn, in Spring Cloud Stream, can I have, let's say, a Kafka and a Rabbit at the same time, meaning I read from Kafka and write out to Rabbit or vice versa? Yes. How do I do that? I add the dependencies. And then we set it up to hook in to maybe a Kafka as an input and a Rabbit as output. So yes, but today we're only using Rabbit because I'm lazy. All right? So the one thing like I told folks is we're living life on the edge today. We are actually, the part of the future here is milestone 5 of Spring Boot is out. Spring Cloud Function and Stream are still on milestone 4. They will be releasing Friday for their milestone 5. So to make sure everything is happy, don't be afraid. But I'm putting snapshot here. I know, I'm a little nervous too. Oh. But here we go. So we're going to refresh that. We're going to go to Project. And we're going to go to Source, Main, Java, UC Application, which again, we'll zoom in there so y'all can see. Can y'all see that? Okay, sweet. If you can't, just squint a lot. And then say, I can't see it. And then what we'll do is this. At Bean, Public, Function. So we're going to include our function here, and we're going to take string as an input, string as an output. String. I actually wanted to hire a professional typist, and they looked at me and went, really? I'm like, have you seen me type? There we go. We'll include function, and we'll call it uppercase, okay? Now, we're going to use all the defaults that Spring Cloud Stream provides, and we're going to return. So it does all the baseline connections for us because, again, Spring Boot, anytime we include that, it's going to give us a set of defaults. It's going to connect us to the Rabbit. It's going to give us the base set of our exchanges and queues, and we're just going to use the defaults for now. I will show you how we change that in a little bit. So we're going to return a string, and then we'll say string dot to uppercase, okay? And we're going to I'll run that. There we go. Run it. Yay. All right, so now what we're going to do here is, I know it's going to be a little bit hard to see, so I'm going to see if I can zoom in just a little bit more. I'm running out of real estate. You are out of real estate, Glenn. All right, so what we're going to do is send a curl command where I'm going to just say, hello, Jconf group. Group. Is that right? Yep, group. And there we go. What did I just do? So I started so in those other two cases, just you can look at the project and see how I did it. The only difference between the code that you see here and the code that's provided in the consumer and supplier is nothing more that instead of having a function here, you would see me say something like supplier, right? Or what? Consumer. Same code. Right, but this time I'm just doing function. Pretty cool stuff, right? And this is just basic Java 8 stuff that we can use today, but kind of building it in with Spring Cloud Stream. So, what we're going to do is we're going to shut this off real quick. 1, 2, and 3. And we're going to go to our next little part of this presentation. So, again, the basics, we focused on functions. Now, I'm going to bore you to death. So for those people who have coffee with you, take a couple of sips, because I am going into story time. So I have this hobby. I love to kayak. It's fun. It's exciting. Okay, but when I go kayaking, a lot of times when I do it, I go with a partner. I go with my daughter, my wife, or my son. Yes, they actually love to do it with me. But now that my children are in college, I have a tendency to go out more by myself nowadays. Sad but true. But when I do go out, I always still follow the same safety protocols. I put on my BFD, I make sure that there's no big boats out there kind of things. But I also make sure I check a few things. Hello, he loves to kayak. Forgot that slide. Okay, in that case, the other thing that I check is I check weather. Because a lot of the streams and creeks I like to kayak can change on a dime. They're very sensitive to the weather. You can see here that one of the, yes, that is really Hog Wallow Creek, is you can see that one of the creeks I love to kayak is usually just below 3 feet. But in a standard summer storm, it goes from 3 to 8 feet in less than 2 hours. At about 4 feet, that is a raging river of death. Okay? So before I go kayaking, I always check a few things. One, I always check the weather. Okay, is it going to rain when I'm on a stream? Then no, I'm not going to be on that creek or river. Just they're too sensitive, right? So I always make sure I check that. The other thing, as you guess, I also go to the United States Geological Survey. They have sensors on all the streams, not all, but a lot of streams, be correct, Lynn, streams, rivers, and lakes across the United States. The cool part about this is I can go out and check them. Now, they won't tell you whether it's dangerous or not. They're just going to tell you what the flow is and how high it is. The closest they'll tell you to what's dangerous is some of them also tell you how much bacteria is in the water, right? I don't know about y'all, but when I go kayaking, I don't want to bring home, I like to go fishing sometimes like to bring home the fish, but I don't want to bring back E. coli. It's just not fun, right? So in this case, on some of those places, they'll actually tell you what the E. coli counts are, at least the estimated counts, right? So really cool stuff that's available to us. So what I did was I decided that, you know what, I feel monolithic today. I feel batchy today. So what I did was I created an application, and it's an ephemeral boot app. And what it's going to do is I run it, it goes out, hits the USGS website, and then says, and I have some criteria that I could deem for safety features or safety. Is it safe for me to go kayaking? So I just plugged in 3 of like the ones I like to go kayaking. One is Outlet River in Lake Panasoffkee, Florida. The other is Big Creek, which is the one that I just showed you on that graph. And the other is right below Peachtree Creek in Atlanta. I like to go kayak this. We're in our dry season. After Ian rolls through, it will not be dry season for us. But for now, we can see that they're all pretty stable, pretty safe. They meet my safety criteria. By the way, if you use my app, do not use it for safety criteria because it's up to me and your safety, da-da-da-da-da. But for me, this is why I deem it safe. I had to say that for lawyers. I don't know why. So in that case, we can see that it's okay. When I look at the application, I did something a little weird. No, Glenn, you do something weird? Never. So in that case, we see that it's nothing more than a Spring Boot application. Actually, I was going to write it as a batch app, and then Oleg said, Glenn, you'll put them and give them a nap. No. So I wrote it as just a regular application runner, standard Spring application runner, right? And in this case, I go out, hit the USGS website, and then you'll see something a little bit different. Instead of just calling methods, I have transformercreek.apply and producereport.accept. Why did I do that? And that's because I said, hey, why don't I just use functions instead? So in this case, I have transform creek measurement, and it just transforms the data from the USGS data to something I can use. And then lastly, I have a produce report. And with a produce report, it goes out and does this testing for me and then gives me a green check if everything's good, or it gives me a red X saying, may not be the best idea to go out. And it is a consumer, because what I'm doing is I'm taking action with the data. I'm not returning anything back. I am just logging that data out. Cool stuff, right? So nothing major there. This is all something we can write. But then Oleg talks to me. He's my stream guru, right? And he's like, you need to write that as a stream. And I'm like, okay, that's cool enough. Well, how do we go about writing it as a stream? Well, let's think about it first. Don't think about streams. Think about what? Testable pieces of code. Let's write some functions here. So what we have is a monolith. I love monoliths. There's nothing wrong with it. I even have a monolith action figure on my desk if you've watched 2001. It's exactly this high, right? Monoliths are great. I'm even going to be giving a talk next year on something called modulates, right, on how to create context within a monolith to be able to make sure the monoliths you create are actually sound, solid pieces of code. So look forward to that talk next year. But sometimes things are also better modeled as microservices, right? So when I look at microservices and I'm saying this might be a good candidate, what are the things that I want to do with my project? Well, I can take the input that I have and create a supplier for the USGS portion. The transform, well, that's actually something that's a little different, where I could take and create a transformer and just take the function I have in my Spring in that application, extract that out, put that in a library along with the USGS source. So I could start creating a function library, have a list of functions in there, put them in a jar, and then share that jar with what? All my apps that can take advantage of those functions. Hard to see, but on the right-hand side, there's supposed to be a little page with like numbers in it. I want to take that report that I had, remember the report thing that determined if it was safe or not to go kayaking, and return and then outputted it. What if I change that from a consumer to what? To a function, where all it does is just tell me whether it's safe or not to go kayaking. But then I create two new syncs and take advantage of that report generator. One, I'll create a log consumer that will just log that data out. I'll create an SMS one that will text me on my watch, right? Instead of me having to go run the app. And then lastly, I'll create a third one that will just take the raw data to store it in a database so I can maybe use that data later. So these are the functions I want to create and that I think I can combine together to create a solution. Well, what do I want to do? What stream do I want to create? I'm going to create what I call a foundation stream. This foundation stream is the basics. I want to take a function and I want to put it into a source and have that be my USGS. I want to take the function that's the transform, and I'm going to put that in there so it'll transform the USGS data to Creek data. And then I'm going to have a output, a final that's going to use my report generator, right? The one that creates that tells me whether it's safe or not. Then I want to take that and compose it with a log function, put them together to create the last output that writes a log. Now, if you look in this corner here, I know the people on camera may not be able to see it, but right here, you're going to see that I'm using something called Enterprise Integration Patterns. Who's ever heard of that? Sweet. How many bought the book? How many times did you log that thing around? I do too. It's pretty close, right? It's close to the heart. Folks, those that don't have it, I highly recommend it. It's basically 65 patterns that say, what are 65 good patterns to show how we can control the flow of data through our application or between applications, right? This was written at a time where their tagline was, very few apps, or most apps don't live in isolation. It is a really cool book. It has things like, it says, hey, transformer, routing, scatter, gather, wiretap, filters. It has all these various patterns that you can take advantage of and shows you, again, how you can control the flow of data between your applications. It was so important that several frameworks created an implementation of it. One is, how many know what CAML is? CAML is an implementation of that. Who's heard of Spring Integration? It is an implementation of the Enterprise Integration Patterns. Spring Cloud Stream, as we're going to be showing, as we already showed you, fits on top of Spring Integration, and therefore, most of the if not all, the patterns that are in the EIP book, that's short for Enterprise Integration Patterns, can be implemented using Spring Cloud Stream. How does that look? So in our basic flow, we kind of see it. I actually used one of them, which is called the transform. But then I want to mutate this stream. I want to change this stream without affecting its original flow. So what I want to do is I want to create a wiretap. A wiretap says, look, I want to get a copy of the data from that main flow, and I don't want to affect the main flow. It's still going to go through, but then I want to create a wiretap where I can go in and start adding new features as I see fit. The thing is that we could see that, hey, I'll go in and add an SMS, right? And so that Glenn could get a text on his watch. I still want to see the data come out on console. But then I also want later on to add one where it's just going to take that data, store that into a database. But then at some time, I don't want my SMS to go through because it's going to buzz my watch because I'm testing it every 15 seconds. I want to shut that down. So I can mutate this base stream by adding and taking away additional services. I want to do that also live. You start to see the value of streaming, how I can handle events as they're coming in and then add value to those events as they're coming in. Pretty powerful stuff, right? By the way, thank other people. They did all the hard work. I just like going, wow, y'all did good. All right, so what is it going to look like? All right, in this case, we're going to break it down here a little bit more. I am going to create a Creek source, right? Again, just going to take and use that function, USGS data. I'm then going to create, and it's going to take and output that data to something called USGS Data Exchange or Topic if you're using Kafka. And then we're going to have a Creek transform. It's going to transform that data, pop it onto the Creek Data Exchange, or if you're using Kafka, Topic. And then what I'm going to do is I'm going to have output that data to either a log queue, an SMS queue, or a repository queue. And this is what it's going to look like in the background, okay? But the important thing I want you to notice is look at these two right here. These two right here, those basically are is that this is going to use the same app. But then I'm going to use function composition and change how the same app behaves. And I'm going to do that dynamically, right? Some of these people are smart. I'm not that smart. I looked at it and went, wow. Okay, so here we go. What does that look like? Hold on, make sure I didn't miss any slides. Okay, we're good. Demo time. Y'all excited? Yay, come on, woohoo, there we go. No pressure, Glenn, no pressure. All right, here we go. So here we go. All right, the first thing we're going to do, again, I'm going to write a function. Okay, I want to write us the transform. Oops, one more thing I want to show you. I'm so excited. I want to write code. Do y'all feel like that? I do. I know, Glenn's weird. Just remember that. He sings, he whistles, and he's weird. All right, but let's take a look at this. It's kind of hard to see, but what we're going to do is this. I'm going to bring up, so this looks very familiar. Okay, there we go. This is the transform Creek measurement. It's the same code we saw from what? The application I have here. I did the best type of coding ever. Copy paste, I was done. Woo! Instant, look at his throughput. All right, no, but what I did was I did a copy paste. I'm taking code that was isolated at one app and I'm going to put it in this, what we call Creek functions. It is a jar that's going to have a list of functions. I'm pushing it to my local Maven repository and install. I'm going to make sure it's available to me in my Maven repository. And what I'm going to do is I'm going to create an application that's going to pull this dependency in. And that way it gives me access to these functions I'm about to show you. The first one, transform Creek measurements. The other thing I'm going to have is, like I said, I changed that consumer that did report Creek measurements and did the generating of that report. Same code, right? I changed it from a consumer to what? A function. I added a new function down here called Creek Measurement Repository. It's going to be a consumer. Come on, there we go. And it's going to be a consumer. And it's going to take in that data, and it's going to, as it takes in that data, what's it going to do? It's going to store that stuff into the database on the slide, right? So what we've got is 3 functions available in the library. I want to use them right now. How can we use that? All right. There we go. So we're going to go back to the second best place on the internet. I'm not going to change any of the dependencies. We're still going to use function, stream, and RabbitMQ. But I'm going to change this name to Transform Creek Measurements, TCM. Not Turner Classic Movies. Oops, I'm not supposed to say that, am I? All right, so we're going to click Generate. And then we're going to go here. We're going to close this out. So I've already pre-compiled those functions. They're ready to rock. That was for time compression. Well, okay, look at time compression. I'll make sure I get y'all out time for lunch. Yeah, I know what's important. So we're going to go here. We're going to open. We're going to go to downloads. We're going to go to, oops, I forgot to do one important thing. Oop. I didn't open my zip. There we go. Now we're going to go back to IntelliJ, click open, and we'll go back to downloads. TCM, open, I trust the project, yada, yada, yada. So again, we're going to go back to the pom.xml, right? And we're going to see The first thing I'm going to do is remember living life on the edge. We're going to change that to snapshot. Y'all don't have to do that after Friday. Actually, after Monday, because they got to update. But Monday, you'll be ready, I promise. Okay. AMQP, function context, Spring Cloud Stream, the rabbit binder. That's it, right? But what do we want to add here? I want to add my new functions library, right? So I'm going to have Creek functions. There we go. I'm going to update my dependencies. Now, all those functions that were in that library, I have to play with. So I want to now take that and make one available for my function. This is going to be the thing that's going to transform the USGS data to what? My Creek data. And the way we do that is we zoom in first. We're going to do this. Public. Oops. I forgot to say it's a bean. Bean. Public. Function. And now what I do, I got to tell it my input. My input is a string. But the output's going to be different. It's going to be a list of Creek measurement. Okay? And I'm going to make sure that everybody knows that Creek, okay. Make sure that's there. And whoop. Yep. Yep, there we go. Very good. And we're going to call it transform Creek measurement. And return, and we're going to return new transform Creek measurement. Okay. My coding is officially done. Okay? But I want to tie these in to specific exchanges in Rabbit or a specific topic. How do we do that? All right? So there we go. Because how many companies allow you to create your topics by yourself? Okay, that's exactly what I expected. Nobody. That's a tightly controlled resource, right? So how do we do that? How do we tell Spring Cloud Stream, don't create those? We want to use what's already there. So what we're going to do is I'm going to make y'all go through a little bit of torture. I don't believe in properties anymore. I like to make people sweat, hurt, and the way I do that is to refactor. Where did I put my refactor? There it is. And I'm going to make it YAML, just because I want y'all to suffer with me. All right, so there we go. We're going to be YAML. But the first thing I want to do is Spring Cloud Stream says, look, you can have any number of functions. Which function do you want me to tie into your topics and queues, right? So I have to tell it which one. Now, by default, if you only have one bean or one function, it'll say, oh, by the way, that's the one he wants to use. I'll use it. But if you have more than one, how do you tell it? So the first thing you're going to do is you're going to do spring.cloud.function. And I'm going to tell it, let me zoom in so y'all can see what I'm doing. Oops. Oh, come on. Zoom. Yay, it works. Okay. And I'm going to tell it I want to use transform Creek measurement. Okay. This is the function I want to tie into my topics or my queues, right? Now, you can have more than one function definition, right? In this case, we're just using one. The next thing I want to do is I want to tell it, how do I want to hook into this given function, right? So I need to tell it what binders I want to have. So in this case, I need to tell it that I want the input of it to be logically mapped to something called input. This can be anything. So what am I doing here is the following. Let me copy paste that. So you'll have to dash out, dash 0. Input. Or output. Oop. Out. And let's see. Out or output? I got to look cheat at my code. Hold on, let me look at the code. I forgot what I called it. There we go. We'll bring in this one real quick. And we'll do a new window. And it's input, right? I think it's output. We'll find out. All will be revealed. Okay. So what we have is the following. Is what I'm saying is here is that I can, in any kind of function, I can have how many inputs? Right now, you can have one, or you have what they call bifunction, which means I can take in more than one input. So the first thing is I'm saying, hey, look, I want to create a logical binder called input, and I want to tie it to 0, index 0 of my parameters that are allowed into that function. I could have 1, 2, whatever I want to have, but in this case, we just have the 1. For the output, believe it or not, you can actually have multiple outputs. Spring Cloud function and Spring Cloud Stream support multiple outputs, so you can do direct routing out. But in this case, we have only one output, so we're going to say 0, okay? So now what we have is if I were to run this right now, it would create 2 exchanges, and the input and output would be the exchanges it would create. But many times, this is more of a logical binder, but what I want to do is tie this directly into something more what we call destination. So we're going to take a look at how we create that destination, because we want a little bit more control of that. So how we do that is we're going to go to Spring Cloud Stream, and we're going to say it was bindings, and that's correct. And I want to cheat. There we go. This is when you start saying, I'm doing presentations, and I got nervous. Never happens. Let's see here. Okay. Here it is. Okay. I was actually right. Okay, that's where I messed up. There we go. Okay. When all else fails, copy paste, right, during the presentation. So what I need to do is say the following. Function, and that's what I should have done right here, bindings. That was it. That was my mistake. And we'll take and copy paste this. Yeah. So what did I just do? I'm going to explain in a second. There we go. Boom. And there. Okay. So what did I just do? So basically what I did was I said, look, I want, again, it goes back to what I said. I want to be able to tie the input and output to this given function right here. But now I want to create what we call our stream. I want to do what's called, I want to tie this directly to my destination. In this case, I want to tie the input and output to a destination on my RabbitMQ. And the way I do that is to say input, and then I say down here, and I say destination. And I said the first one I want to take in is my input. I want to get it from USGS data. I want to have a group, and we'll just call group right now foo. In this case, it's going to create a queue called foo. Output. The destination here is what? Creek data. And group is foo. There we go. Now, we will go out to our RabbitMQ. Oh, did I misspell something? Thank you. Oh, see, you get an award from me. Thank you. So in that case, it's exactly correct. So what we're going to do is actually then we're going to go out to here, and we'll see in our exchanges. We're going to zoom in here. We'll see we have the uppercase in and out. The USGS data, whoops, I already created it earlier. I was doing a test to make sure everything worked, so it was already pre-created. Should have, but actually that's a good sign. So what we'll use is existing USGS data. We'll run this. We see that it's running. And then we'll see where it actually creates, and we'll do a refresh here. And we'll see that it just created the Creek data. So by default, Spring Cloud Stream will create the exchanges for you that you declared within your destination bindings. But you can set a flag that says, do not auto-create, and what that means is it'll honor that, and it's if it tries to start, doesn't see the topic, it won't try to create it or queue. It will fail and say, hey, the topic or queue is not there. So it honors what you'll have as a standard. So with that being said, now it is up and running. We see that it's created the queues that I need in the exchanges. So what we're going to do now is we're going to start our Creek consumer, and actually choose the right place there. And no, it's right here. There we go. We'll start our Creek consumer. And the Creek consumer, right now, we're using the defaults for it. And the defaults for it is as follows. And let's see. Recent projects, Creek consumer. New window. And we're going to see that there's no magic here. Again, what it has is, zoom in. It's going to have the log. It's going to have the generate report. So I have two functions there. It also has the SMS function. Remember, I want to also get it on my watch, right? So I'm going to get it on my watch, I'm going to get it on my log, and I want to use the same app to do that. So how do I do that? Here's the fun part. And this is where it's like, I'm a bad speaker, but they're great developers. And y'all are great developers too. So in this case, the definition changes. I'm going to use the generate report function. I'm declaring that as a definition. But then you see what? I'm outputting it to log. That's function composition. I'm saying the output is going to log. But you also see the bindings change a little bit. I said generate report log -n0. That's all I have to declare for a consumer. You're like, Glenn, that's a function there. Yeah, but the function output goes to where? To the consumer. Dead ends, right? What's the action of this particular consumer? Log it to the output. Then we see the destination binding. It's going to the Creek data. You start to see how this is shaping up? So now I've got the consumer running. I'm going to go ahead and start the source. It's going to start pushing data out to my transformer. The transformer is now working. It is now outputting the data here. And I gotta zoom out a little more. Come on, you can do it, Glenn. A little more. There we go. And we can see that it's actually working, right? But that's not enough. I want to do more, right? How can we do more? I want to mutate the stream. We've got the base stream going. In this case, I'm going to use the same project, the same consumer, but the output is going to change. Notice the definition's changed here. It might be hard to see. Let me zoom in a little bit more. We change it to SMS. Again, the binding changes to generate report SMS. Again, it's taking only input, not output. And we are also changing the group, the queue it's going to listen to. It's going to listen to queue SMS. Now we're going to see, okay, hold on, let's do this. All right, and, oh, how's the family? Doing good? Hello. Okay, and I got it on mute. All right, hold on. So there's my kayaking report. So, yay! Now, in order for me to prevent me from going crazy with my watch going buzz, 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 because I just got 2 more messages coming, ow, 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 it's electric shock, I'm going to change this. I just disabled it. But if we look here, the regular flow is still going. It goes back into that mutation. But then we can go in here and say, okay, and no magic up here. We're going to do, we see that there's no Creek data here. But what we will do now is start the last consumer. And that's right here. And this is going to take in the data. Boom. Okay, it's going, yay, 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 boof, there we go. And we will see, okay, let's go back to here, here. Okay. And on the next report, it's going to create the Creek data table. Come on. I have it on 15 seconds, so this is the way I could stretch my talk out. There we go. And we will now refresh. See that create a Creek measurement table. View data. Now, so when we think about streams, our goal is create functions, test functions in isolation, use the frameworks to hide that infrastructure from us. Then when it's time for us to plug it in, we bring in the right dependency. In this case, it's stream, but if you're using web, right, you can pull in web. Expose these functions as endpoints on a web. In a stream, you can expose them as what? As source processor or sinks. Then lastly, the other thing to think about is that from a function point of view, you can also drop these on also many function providers out there, right? The Amazons, whatever. You can take that function and drop them out there too. The advantage to also using Spring Cloud Function is not only does it give you that isolation, it gives you the full power of Spring Boot in a function. So keep those things in mind. That's the power of this. Now, what we're going to do is, the good news is my demo time is over. I didn't sing a song, but I need to tell you about 2 more things here. Okay, we're going to play from current slide. Here we go. And just one more thing. As you're creating these streams, and you're thinking about the orchestration or thinking about it, usually what happens is we don't just create 1, 2, 3, or 4 streams. We start creating literally hundreds or thousands of streams. It becomes that point where you're saying it becomes a valuable resource. I need to be able to orchestrate these things. Okay? When I say orchestration, I mean the pushing these things out to Kubernetes, pushing these out to my own infrastructure, right? Or even to like a Tanzu application service, any one of those, right? How can I do that and make sure that I do that at the time in which I'm doing a CI/CD, right? My CI/CD fix is successful. Upon success, push that stream out there. Or, hey, we've just created a new sync that we want to have out there. We push it out there. How can I hook that into an existing stream? That's orchestration, right? It's also, I've got a stream that's running, it's happy, but I want to change the transform. I want to change it from version 1.0 to version 2.0. Oops, 2.0 is not working. I want to roll it back. That job is for Spring Cloud Data Flow. Spring Cloud Data Flow allows you to orchestrate the creation of your streams in batch jobs and be able to deploy these out to Kubernetes or to your infrastructure and do exactly what I'm saying here. I know that's kind of hard to see because of the washout, but the goal is here is I want you to be able to see that you can use their UI and create the streams by drag and drop, or you can use their syntax language and use that as a part of your CI/CD to push out RESTful requests to have Dataflow do that for you. Okay? And I've got 6 minutes left. And for questions, if those people are starving to death, please go get some food. But for the rest of y'all, just one more picture. Okay? This is to prove that people didn't go to sleep. All right, hold on, let me do this. All right, here we go. And everybody say, we're awake! Hey, there we go. Thank you, folks. Y'all have a great day. Any questions before you? Yeah.
I noticed in your application YAML file you were doing, input, output, binding, input, blah, blah, blah.
Yeah.
Are those Spring keywords, or could you have named it anything you wanted and just made maintaining miserable?
What do you mean? Okay, so let's go back to the demo on that. All right. Do y'all want pictures of that? That's where the location of the project is. So it's GitHub CPP WFS, and then that tag. Vowels are good. I just don't use them. Okay, there we go. All right. So let's go back to the demo. So, all right. So you see that? Okay. What's the question here?
Yeah. So
I'm going to go. Okay.
I get that. N, I get that. 0, I get that. And then you have input.
Yeah.
And then under there you have bindings input.
Yeah.
Are those
like right here?
Yeah. Like are those 2 inputs? Are those special keys, or are they just, or could you just name them? Okay, all right.
Exactly. It's whatever you want. I just use input because that's the most common descriptive way. But see, the thing is that it could be like you would have this as an example. You know, you can actually go in and have more than one function definition, right? And as we go in and add more function definitions, you're going to increase your number of bindings. So what we're creating here is the ability to have n number of functions that are there, declaring the definition of how I want my app to behave. And then the bindings are really logical, especially at this level, it's logical. The reason we did that was so I can have, like, again, the foo as an example here, and then I stop. I don't have this destination portion here. Boom. I declare it, I document it, and then when the person deploys it to production, they can come in at production time, and when they launch it through environment variables, like right here, and I did it as command line though. Right, I'm going to zoom in really tight here so y'all can see it. They changed the very definition and chose how they want to hook it in and where they want it to go. I should have actually put destination here too, but I was lazy. But the point is that I can go in and change it. And also there's other properties in there like, you know, what's the location of the RabbitMQ? What's its URL? What's its passwords? What's all the good stuff to be able to get the hook in? Do we want to automatically create the topics or exchanges? Do we want to, oh my gosh, what's the others? What's the policy on the exchange or topic? all those values that are exposed through Kafka and RabbitMQ, among all the others, are exposed. One of the powers of Spring Cloud Stream is it says, look, our job is to not get in the way of the strength of that given messaging framework. We are just simplify your access to it. Because as we know, the behavior of Kafka, Rabbit, Google PubSub, Pulsar, all of them are different, right? Each one has its particular strength and weakness. We don't want to get in the way of that. We just want to make sure that you can focus on the function. Great question. Any others? Yes, sir.
Yeah, so I was just curious, like if we have to, let's say, purge the data of, let's say, this is more like real time, whatever on the USGS website, you were just pulling it in.
Yes.
So you want to collect all those data like for an hour and purge it and now generate analysis on top of that.
Yeah.
That go in, I mean, what is the recommendation for us to use it as part of the, the processor or after the sync? Like, what is the best?
To purge the data from the upstream system. Now, in that case, what you could do is it could be a source where you return an ACK back. Remember, the source is kind of wide open, right? I could have sent, but part of the thing that you'll see here, like even in this example, when I did the curl command, it does basically acknowledges a 200 back, right? You can say, hey, we received the data. Okay, send a reply back at that time. I've just dropped it onto the queue. Come to think of it, it's probably better done at the processor time because the processor can, I'm trying to think, what would be the solution? Because what you want to make sure is so one of the things you can do is a post process on that where you say, I know that I've dropped it onto the exchange or queue, or so exchange or topic, and then as a post process say, okay, now let the upstream system know, remove it. And so you can do that through a post process, right? In this case, because what it is, until that value was returned, it returns that value back out, drops it onto the topic or queue, it's not done yet. So you can't return, you can probably return a 200 saying I got it, but you're not delivered it to the messaging framework. So you're going to do that as a post process. Okay. Anything else? Well, folks, thank y'all for coming. Y'all have a great day.